Okay, so today we talked about concentrations and solutions. So before we actually find how to find the concentration of a solution or how to deal with it, we need to talk about what a solution is again. So a solution is also known as a homogeneous mixture. And so if you remember from the beginning of the year, and it was a long time ago, this means specifically that it all looks like one thing. So like salt water is a mixture of salt and water, but it all looks the same. And so that's a solution. Also, air is a solution because it's got nitrogen. It's mostly nitrogen and oxygen, carbon dioxide, hydrogen, helium, okay, and a few other gases. So that's what a solution is. Now, a solution is made up of two things. Let's see. It's made from a solute and a solvent. So the solute is the substance that dissolves. And the solvent dissolves the solute. So if we were to take salt water or salt, sodium chloride, and put it in a container that has water in it, then the salt would be the solute and the water would be the solvent. Okay? So if we look at all of this together, then we would see this. All right, so you need to understand these concepts when we're talking about concentration. Okay, so what is concentration? Concentration in chemistry is a numerical amount that represents the amount of solute that is dissolved per specific amount of solvent. All right, so what does that mean? You've seen this in places before. You've seen it on like bottles of alcohol where it would say 70% isopropyl alcohol. That's a concentration of the alcohol in the container. So it's not all alcohol, the rest is probably water. You've seen it on hamburger meat where it would say like 93%, 10%. And so that's a ratio of meat to fat. You've seen it on milk, antifreeze, bleach. So we do know what concentration is, and you've seen it before in day-to-day life. But the concentration that we typically use in chemistry is not a percentage like these are. These are usually mass percent or volume percent. So what we use in chemistry most of the time is called molarity. And molarity is represented by a capital M, not a lowercase m, that's something different. So a capital M is molarity, and it's moles of the solute that's dissolved divided by the liters of the solution. Okay. So it's liters of the total solution, and I'll abbreviate solution from now on, SOLN. Okay, so if you have a 3 molar solution, say we have a 3 capital M salt solution. That means, and we would say this is 3 molar, that represents molarity. Okay, that means that in one container, 1 liter container, so we have a 1 liter container, there are 3 moles of salt in there. Remember, a mole is not a molecule. A mole is a whole bunch of molecules. It's 6.02 times 10 to the 23rd molecules. So in that 1 liter, you would have that many molecules, 3 times 6.02 times 10 to the 23rd. So that's what molarity is. Okay? Now, we're going to do some examples so that you can be successful on these. It's not very hard to do. You should catch on pretty quickly. We have 28 grams of sodium chloride per liter, and so what that tells me is that I have 28.0 grams of sodium chloride in 1 liter of water. So I can write it like this. So that's what that means. Per means you have 28 grams of sodium chloride in every liter. And we want to know what the molarity is. And so if we remember what molarity is equal to moles over liters. So really what we're looking for is we're looking for how many moles there are in every liter. Now, I've got grams over liters. I just need to change my grams to moles. And so in order to go from grams to moles, I'm going to use the molar mass. And the molar mass of sodium chloride is 58.44 grams in 1 mole. So if I take 28 divided by 1 times 58.44, or divided by 58.44, I end up with, this is going to equal 0.479 moles per liter, because the grams canceled out. And I could also write that as 0.479 and then with a capital M, so 0.479 molar. So both of these answers mean exactly the same thing. Okay, so in this problem we've got 5 grams of sodium hydroxide that's dissolved in 750 milliliters of solution, and we're wanting to know what the molarity is. So the molarity is equal to the moles over liters, so that's really what we're looking for. We're looking for moles divided by liters. And I've got 5 grams of sodium hydroxide. And I've got 750 milliliters of solution. So it's going to be, the grams needs to change into moles, and the milliliters has to change into liters. So if I have to change grams to moles, I'm going to use molar mass, and the molar mass of sodium hydroxide is 40. Oh my God. So 5 divided by 40 is 1/8, or 0.125 moles. So that's first. And then I've got 750 milliliters, and that has to be changed to liters. So if you still can't remember if you have to multiply or divide, or how much it is, you can just use this, okay? And that's just kilo and milli at the, here, I'll use, this down here is kilo, and this up here is milli, and then this would be your base unit, like meter or liter or whatever. So if I have milliliters, then I'm going to start right here, and I'd want to go back to liters, so I'm going to move the decimal place back 3 places. So here's my decimal, 1, 2, 3, and so that's the same thing as 0.75 liters. So I'm going to take 0.125 moles and divide it by 0.75 liters in order to get moles per liter here. So I've got, let's see if I can, whoops. .125 moles from at the top, and then we're using 0.75 liters, and so that would give us 0.167 molar. All right, let's do one more. Okay, so in this one, it says how many moles. So I'm looking for moles, and I've got 10 liters, and it's a 2 molar solution. So anytime I see that I have a concentration given in molarity like this, I change it to moles per liter, because that tells me more information than just one big M. And if we want to find something like moles, and you're given 2 amounts, you always use the number that does not have any units in the denominator. So this number does not have any units in the denominator, while this one has liters in the denominator. So we're going to start with this one because it doesn't have anything in the denominator. So I start with 10 liters. And then I know I want to end up with moles, so I look at my numbers given to me and I try to figure out how I can get moles. And I've got moles right here. So all I have to do is get rid of liters. So if I put 2.0 moles per liter like that, then liters cancels out and I end up with moles. And so that's going to be 20 moles. All right, and then we're going to do one more. So what is the volume in milliliters of a 12 molar hydrochloric acid solution and is needed to contain 3 moles of hydrochloric acid? So I've got 12 molar, and remember, you're going to change the big M to moles per liter. And we've got 3 moles. So which one am I going to start with? This one has a unit in the denominator, so I'm not going to start with that. I'm going to start with this one first. So I start with 3 moles. And then I want to get milliliters. So that means that I'm going to have to find liters in order to get milliliters. So then I look at my other number, and I want to get this. And I have moles right here. So that means that this moles has to go on the bottom to cancel it out. So it's going to be 12.0 moles per liter. So mole cancels out, and I'm left with liters. So 3 divided by 12 is 1 over 4, or 1/4, which is 0.25 liters. And so if we want milliliters, and I've got liters, this time I'm going to move it 1, 2, 3 forward, and so I get 250 liters. So that's the answer.